Welcome to Dreamy Facts. As the day gently recedes, we invite you to settle into a space of calm contemplation. Tonight, we embark on a journey through the vast and mysterious expanse of astronomy, exploring approximately 100 fascinating facts that reveal intricate patterns, subtle wisdom, and profound beauty within our universe. There is no pressure to remember or retain these details. Instead, let them unfold naturally, inviting your mind to settle into a state of peaceful curiosity. This exploration is designed to be a soothing experience, a gentle current of knowledge flowing without demanding effort or retention. We will observe the intricate dance of celestial mechanics, the subtle adaptations of cosmic structures, and the quiet wisdom embedded in the very fabric of space and time. Each fact is a small window into the vast and interconnected tapestry of the cosmos, presented in a calm and meditative tone, allowing your thoughts to drift and find stillness. Allow the gentle rhythm of these discoveries to guide you towards a state of relaxation, inviting a sense of wonder and peace as you prepare for rest. If you're finding peace in this journey, a like and subscribe helps us continue creating these restful explorations. And we're always curious. Share in the comments what city and time zone you're watching from. There's something special about knowing this experience is reaching people all over the world as they prepare for rest. We begin our journey by looking at the fundamental building blocks and overarching structures that define our universe. Let us gently consider the immense scales and the powerful forces that shape everything we observe, inviting a sense of profound wonder at the cosmos. The universe operates on scales almost unimaginable to the human mind, stretching beyond our immediate comprehension. Scientists have observed that the observable universe, the portion we can theoretically see from Earth, spans approximately 93 billion light-years in diameter. A light-year, a unit of astronomical distance, represents the distance light travels in one Earth year, which is about 9.46 trillion kilometers or 5.88 trillion miles. This immense scale means that light from the most distant objects we can detect has traveled for billions of years to reach us, offering a glimpse into the universe's past. Current understanding suggests that the true universe extends far beyond this observable limit, though its full extent remains a profound mystery. The sheer number of stars within the observable universe is estimated to be greater than the number of grains of sand on all the beaches on Earth, showcasing the incredible density of luminous matter in some regions. This vastness is not static. The universe is continually expanding, carrying galaxies further apart from one another. Galaxies are vast cosmic islands, each containing billions to trillions of stars, gas, dust, and dark matter, all bound together by gravity. Astronomers classify galaxies into several main types based on their visual morphology, including spiral, elliptical, and irregular galaxies. Spiral galaxies, like our own Milky Way, feature a flat, rotating disk with spiral arms extending from a central bulge, often containing younger, bluer stars and active star-forming regions. Elliptical galaxies, in contrast, are generally older and more spherical or egg-shaped, with stars orbiting in random directions and little ongoing star formation. Irregular galaxies lack a distinct regular shape, often resulting from gravitational interactions with other galaxies or turbulent internal processes. Research indicates there are likely hundreds of billions, if not trillions, of galaxies in the observable universe. Our Milky Way galaxy is part of a larger structure known as the Local Group, which also includes the Andromeda Galaxy, its largest neighbour. The Andromeda Galaxy is currently on a collision course with the Milky Way, a cosmic event predicted to occur in about 4.5 billion years, eventually forming a new, larger elliptical galaxy. Stars. Cosmic furnaces. Stars are the fundamental powerhouses of the universe, massive luminous spheres of plasma held together by their own gravity. The life cycle of a star begins within dense clouds of gas and dust known as molecular clouds, where gravitational collapse initiates the formation of a protostar. As the protostar contracts, its core temperature and pressure rise until nuclear fusion ignites, primarily converting hydrogen into helium, marking its entry onto the main sequence. Our Sun is a main sequence star, and it has been fusing hydrogen for about 4.6 billion years. The colour of a star is an indicator of its surface temperature. Hotter stars tend to be blue or white, while cooler stars appear orange or red. Stars vary enormously in size, from tiny red dwarfs, which can live for trillions of years, to colossal hypergiants, which burn through their fuel in just a few million years. The immense energy released by stars through nuclear fusion is what powers light and heat across the cosmos, creating the elements heavier than hydrogen and helium through stellar nucleosynthesis and supernova explosions. Nebulae, stellar nurseries and graveyards. Nebulae are vast interstellar clouds of dust, hydrogen, helium, and other ionized gases, serving as both the birthplaces and the remnants of stars. Emission nebulae, such as the Orion Nebula, glow brightly as the intense ultraviolet radiation from nearby hot, young stars ionizes the hydrogen gas within them, causing it to emit light in specific wavelengths. Reflection. Nebulae, on the other hand, do not emit light themselves, but rather reflect the light from nearby stars, often appearing blue due to the scattering of blue light by dust particles, similar to why Earth's sky is blue. Dark nebulae are extremely dense clouds of dust and gas that absorb and block visible light from objects behind them, appearing as dark silhouettes against brighter backgrounds like the Horsehead Nebula. Planetary nebulae are formed when a dying star, similar in mass to our Sun, sheds its outer layers into space, creating a glowing shell of gas around a hot, dense core called a white dwarf. Supernova remnants are the expanding clouds of gas and dust left behind after a massive star explodes in a supernova, enriching the interstellar medium with heavy elements crucial for future star and planet formation. Black holes, gravity's ultimate domain. Black holes are regions of space-time where gravity is so incredibly strong that nothing, not even light, can escape. They form from the remnants of massive stars that collapse under their own gravity after exhausting their nuclear fuel, an event known as a supernova. The boundary around a black hole beyond which escape is impossible is called the event horizon. Anything crossing this boundary is irrevocably drawn into the black hole. Scientists have observed three main types of black holes. Stellar mass black holes, which are typically 3 to 20 times the mass of our Sun. Supermassive black holes, found at the centers of most large galaxies, ranging from millions to billions of solar masses, and intermediate mass black holes, which are less understood but thought to be between stellar and supermassive types. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius A star, SGR A star, with a mass estimated to be over 4 million times that of the Sun. While black holes themselves are invisible, their presence can be inferred by their gravitational effects on surrounding matter, such as the orbits of stars or the emissions from accretion disks of gas spiraling into them. Dark matter and dark energy. Our current understanding of the universe suggests that the ordinary matter we can see and interact with, stars, planets, gas, makes up only about 5% of the cosmos. The vast majority, approximately 27%, is attributed to an enigmatic substance called dark matter. Dark matter does not emit, absorb, or reflect light, making it invisible to telescopes. Its existence is inferred solely through its gravitational effects on visible matter, such as the rotational speeds of galaxies and the gravitational lensing of distant objects. Without dark matter, galaxies would simply fly apart. The remaining 68% of the universe is thought to be composed of dark energy, an even more mysterious force responsible for the accelerating expansion of the universe. Scientists have observed that distant galaxies are moving away from us at an increasing rate, a phenomenon that cannot be explained by gravity alone. Current theory suggests dark energy acts as a repulsive force, counteracting gravity on cosmic scales. The nature of both dark matter and dark energy remains one of the most significant unsolved puzzles in modern astronomy, representing fundamental components of the universe that are yet to be directly detected or fully understood. Cosmic Microwave Background, CMB. The cosmic microwave background, CMB, is faint radiation filling all space, considered one of the most compelling pieces of evidence supporting the Big Bang theory. It is essentially the afterglow of the Big Bang, a relic heat from the universe's infancy. Approximately 380,000 years after the Big Bang, the universe had cooled sufficiently for protons and electrons to combine and form neutral hydrogen atoms, a process known as recombination. At this point, the universe became transparent to light, and the photons that had been scattering off free electrons were finally able to travel freely. These ancient photons, stretched by the universe's expansion over billions of years, are what we detect today as the CMB. Scientists have observed that the CMB has an incredibly uniform temperature across the sky, currently measured at about 2.725 Kelvin, approximately minus 270.425 degrees Celsius, but with tiny fluctuations. These minuscule temperature variations, detected by missions like COBE, WSAP, and Planck, represent the seeds from which all the structures in the universe, galaxies, clusters, and superclusters, eventually grew. The Big Bang Theory. The Big Bang Theory is the prevailing cosmological model describing the universe's earliest known periods and its subsequent large-scale evolution. It posits that the universe began as an extremely hot, dense point approximately 13.8 billion years ago, and has been expanding and cooling ever since. This expansion is not an expansion into space, but rather an expansion of space itself, carrying galaxies along with it. Key observational evidence supporting the Big Bang Theory includes the aforementioned cosmic microwave background radiation, which provides a direct snapshot of the early universe. Another crucial piece of evidence is the observed redshift of distant galaxies, indicating that they are moving away from us, and the further they are, the faster they recede, consistent with a uniformly expanding universe. Furthermore, the Big Bang Theory accurately predicts the abundance of light elements, hydrogen, helium, and lithium in the universe, which were formed during the first few minutes after the Big Bang through a process called Big Bang nucleosynthesis. While the Big Bang describes the expansion and evolution of the universe, it does not explain what existed before the Big Bang or what caused it. Quasars and active galactic nuclei. Quasars are among the most luminous and energetic objects in the universe, often outshining entire galaxies. They are a type of active galactic nucleus, AGN, powered by supermassive black holes at the centers of distant galaxies. As gas and dust spiral into these central black holes, they form an accretion disk, which heats up to extreme temperatures due to friction and gravitational forces. This intensely hot material emits vast amounts of radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Scientists have observed quasars predominantly at very large distances, meaning we see them as they were billions of years ago, providing insights into the early universe. The immense energy output of quasars suggests that the supermassive black holes powering them are actively accreting matter at incredibly high rates. AGNs, including quasars, play a significant role in galaxy evolution, as the energy they release can influence star formation in their host galaxies. The study of quasars helps astronomers understand the growth of supermassive black holes and the conditions of the young universe. As we gently drift through these foundational concepts, we begin to perceive the universe not as a chaotic void, but as an intricately structured, dynamic, and ever-evolving entity. Each component, from the smallest atom to the largest galaxy, plays a role in this grand cosmic ballet, revealing a universe of profound order and boundless wonder. As our gaze gently recedes from the grand, overarching structures of the cosmos, from the swirling majesty of distant galaxies and the profound mysteries of dark matter and energy, we now invite you to turn your quiet contemplation a little closer to home. Imagine, if you will, a soft ethereal light guiding us inward, past the luminous veils of nebulae and the silent gravitational pull of black holes, to a place both intimately familiar and endlessly astonishing, our very own solar system. Here, amidst the intricate dance of celestial mechanics, we discover a vibrant, dynamic neighborhood, a collection of planets, moons, and countless smaller bodies, all bound by the benevolent embrace of our Sun. This is our cosmic home, a sanctuary of ordered motion within the vast, bewildering expanse, offering a renewed sense of peace as we allow our thoughts to drift and find stillness. At the very heart of this intricate system, radiating warmth and light across billions of miles, resides our Sun, a magnificent, vibrant star. It is a main sequence star, a cosmic furnace tirelessly fusing hydrogen into helium deep within its core, a process that has continued for approximately 4.6 billion years and will persist for another 5 billion or so. This stellar alchemy is the very engine of life on Earth, providing the energy that sustains our planet's delicate biosphere. We observe its surface, a seething, turbulent sphere of superheated plasma, marked by sunspots, cooler, darker regions where intense magnetic activity suppresses heat flow, and occasionally witnessing spectacular solar flares and coronal mass ejections, which are colossal bursts of radiation and charged particles erupting into space. These powerful events, while beautiful to behold from a safe distance, remind us of the immense, untamed energy inherent in our nearest star, a constant glowing anchor in the cosmic sea. Its immense gravitational pull orchestrates the graceful orbits of all the planets, dwarf planets, asteroids, and comets that comprise our local family, holding them in a delicate gravitational embrace that defines our cosmic neighbourhood. Venturing outward from this stellar core, we encounter the inner rocky worlds, a quartet of terrestrial planets, each a unique testament to the diverse processes of planetary formation. Closest to the Sun, Mercury spins, a small, heavily cratered world of extremes, where temperatures swing wildly from scorching daytime highs that can melt led to frigid nighttime lows, all due to its virtually non-existent atmosphere. Its surface bears the scars of ancient impacts, a silent record of the early tumultuous solar system. Next, shrouded in a thick toxic atmosphere of carbon dioxide, lies Venus, a planet of paradoxical beauty and infernal conditions. Its dense atmosphere traps heat in a runaway greenhouse effect, making it the hottest planet in our system, hotter even than Mercury, with surface temperatures capable of vaporizing lead. Mysteriously, Venus also rotates in retrograde, meaning it spins in the opposite direction to most other planets, causing the sun to rise in the west and set in the east, a truly unique celestial ballet. Then, we arrive at our own blue marble Earth, a vibrant oasis shimmering with liquid water, a dynamic atmosphere, and the miraculous abundance of life. It is the only known planet in the universe to harbour life as we understand it, a testament to its precise distance from the Sun within the quote one where temperatures allow water to exist in its liquid state. Our planet's powerful magnetic field, generated by its molten iron core, acts as an invisible shield, deflecting harmful solar radiation and protecting the delicate conditions necessary for life to thrive. And further out, the red planet, Mars, beckons with its rusty hues and compelling mysteries. Scientists have found compelling evidence of ancient riverbeds and polar ice caps composed of water ice, suggesting that Mars once harboured vast oceans and a thicker atmosphere, potentially supporting microbial life. Its two small, irregularly shaped moons, Phobos and Deimos, are believed to be captured asteroids, silently orbiting their ruddy host as humanity dreams of future exploration. These inner planets, though sharing a rocky composition, each tell a distinct story of formation and evolution, inviting us to ponder the intricate conditions that allow for such profound diversity beyond the inner worlds across the vast expanse of the asteroid belt, a region teeming with millions of rocky remnants from the solar system's formation. We encounter the majestic gas and ice giants, colossal worlds that dominate the outer reaches of our planetary system. First, Jupiter, the undisputed monarch, reigns supreme, a swirling behemoth of hydrogen and helium, so massive it could contain all the other planets in the solar system combined. Its most iconic feature is the Great Red Spot, a colossal anticyclonic storm larger than Earth, which has raged for at least 350 years, a testament to the planet's turbulent dynamic atmosphere. Jupiter also boasts a faint system of rings and a retinue of dozens of moons, including the 4 Galilean moons, Io, Europa, Ganymede, and Callisto, each a fascinating world unto itself, holding secrets of volcanism, subsurface oceans, and ancient scarred landscapes. Next, with its breathtaking intricate system of countless icy rings, Saturn gracefully orbits, a true jewel of the night sky. These rings, composed of billions of ice particles ranging from microscopic dust to house-sized boulders, are so thin that they are only tens of meters thick, yet they span hundreds of thousands of kilometers, creating an ethereal, shimmering spectacle. Saturn itself is a gas giant, much like Jupiter, but famously possesses a remarkably low density. If a sufficiently large bathtub existed, Saturn would float. Its atmosphere, too, is a realm of powerful storms and swirling cloud bands, though often more subdued than Jupiter's. Farther still, we encounter the ice giants. Uranus, a serene, pale blue world distinguished by its extreme axial tilt, essentially orbiting the Sun on its side, a cosmic tumbleweed. This unique orientation results in extreme seasonal variations, with each pole experiencing decades of continuous daylight, followed by decades of darkness. And finally, at the outermost reaches of our known planetary neighbours, Neptune, a deep blue giant, lashes with the fastest winds in the solar system, often exceeding 1,200 miles per hour, creating transient features like the Great Dark Spot, a storm comparable to Jupiter's iconic feature. These giant planets, with their swirling atmospheres, complex ring systems, and diverse families of moons, offer a profound sense of the grandeur and dynamic forces at play in our cosmic neighbourhood. As we continue our gentle journey outward, we encounter not just the major planets, but also a host of smaller, yet equally fascinating celestial bodies that populate our solar system. The concept of planet itself has evolved, leading to the classification of dwarf planets, which, like their larger counterparts, orbit the Sun and are massive enough to be rounded by their own gravity. But unlike true planets, they have not cleared their orbital neighbourhood of other debris. Pluto, once considered the 9th planet, is now the most famous of these, residing in the distant Kuiper belt, a vast ring of icy bodies beyond Neptune. Pluto, with its heart-shaped glacier and large moon Charon, offers a glimpse into the frigid, distant reaches of our system. Other notable dwarf planets include Ceres, the largest object in the asteroid belt, and Eris, Makemake, and Haumea, all residing in the Kuiper belt, each a testament to the diversity of worlds beyond our traditional understanding. Beyond the dwarf planets, our solar system is a cosmic junkyard, teeming with the remnants of its formation, asteroids, rocky fragments ranging from pebbles to hundreds of miles across, primarily congregate in the main asteroid belt between Mars and Jupiter, but also exist as near-Earth asteroids, occasionally crossing our planet's path. Comets, on the other hand, are icy wanderers, often originating from the distant Oort cloud, a spherical shell of icy objects thought to encompass our solar system, or the Kuiper belt. As a comet approaches the Sun, its ice vaporizes, creating a magnificent glowing coma and a characteristic tail that can stretch for millions of miles, a breathtaking celestial spectacle. And then there are meteoroids, small pieces of asteroids or comets. When these enter Earth's atmosphere, they burn up, creating a fleeting streak of light we call a meteor or shooting star. If a piece survives its fiery descent and lands on Earth's surface, it becomes a meteorite, offering scientists tangible samples of extraterrestrial material, allowing us to hold pieces of cosmic history in our hands. These smaller bodies, far from being mere debris, are invaluable archives, preserving clues about the early conditions and processes that shaped our solar system. Closer to home, and perhaps most intimately connected to our daily lives, is Earth's own moon, a silent, luminous companion that profoundly influences our planet. Believed to have formed from the debris of a colossal impact between early Earth and a Mars-sized protoplanet, our moon is tidally locked, meaning it always presents the same face to us, a familiar friend in the night sky. Its gravitational pull is the primary driver of Earth's ocean tides, a constant rhythmic force that shapes our coastlines and marine ecosystems. The moon's phases, from the slender crescent to the full luminous orb, have inspired poets, artists, and dreamers for millennia, a gentle reminder of the celestial ballet unfolding above us. Beyond our moon, the solar system is rich with fascinating satellites. Jupiter's moon, Europa, for instance, holds a vast subsurface ocean beneath its icy crust, a tantalizing prospect for harboring extraterrestrial life. Saturn's Titan, unique among moons, possesses a thick, nitrogen-rich atmosphere and liquid methane lakes and rivers on its surface, a world eerily reminiscent of early Earth. And Enceladus, another of Saturn's moons, actively spews plumes of water ice into space from its south pole, indicating a subsurface ocean with hydrothermal activity, another prime candidate in the search for life beyond Earth. These diverse moons, each a miniature world with its own geological activity and atmospheric phenomena, add layers of complexity and wonder to our understanding of planetary systems. As our gentle exploration of our cosmic neighbourhood draws to a close, our gaze expands once more, not to the far reaches of the universe, but just beyond the boundaries of our own solar system, to the realm of exoplanets. These are planets that orbit stars other than our Sun, and their discovery has revolutionized our understanding of planetary formation and the potential for life elsewhere. Scientists have now confirmed the existence of thousands of exoplanets, utilizing ingenious methods such as the transit method, where they detect a slight dimming of a star's light as a planet passes in front of it, and the radial velocity method, which measures the wobble of a star caused by the gravitational tug of an orbiting planet. What we have found is astonishing diversity. Hot Jupiters orbiting incredibly close to their stars, super Earths much larger than our own, and even rogue planets drifting alone through interstellar space, unattached to any star. They search for exoplanets within the habitable zone of their host stars, the region where conditions are just right for liquid water to exist on a planet's surface, is one of the most exciting frontiers in astronomy, fueling our deepest curiosity about whether we are truly alone in this vast cosmos. Each new discovery deepens our appreciation for the sheer abundance of worlds, reminding us that the universe is far richer and more varied than we could have ever imagined. As we gently bring our focus back to the quiet space you inhabit, allowing these profound facts to settle within you, consider the incredible journey we have undertaken through our own cosmic neighbourhood. From the life-giving embrace of our Sun to the intricate dance of its planets and moons, and out to the countless exoplanets beyond, we find an astonishing tapestry of order, beauty, and dynamic processes. The very existence of our solar system, with its unique conditions for life on Earth, is a delicate balance, a harmonious arrangement of gravitational forces and cosmic evolution. Let this understanding foster a sense of profound peace, a quiet wonder at the interconnectedness of all things, great and small. May these dreamy facts about our local universe gently guide your thoughts, offering a serene perspective as the day gently recedes and you prepare for rest, knowing that you are a part of this magnificent, ever-unfolding story. As the cosmic dust of distant exoplanets settles gently in our minds, we now turn our gaze to the very instruments that allow us to perceive these wonders, these faint whispers from across the vastness. For it is through ingenuity and profound curiosity that humanity has extended its senses beyond the limitations of our earthly perspective, enabling us to truly embark on this journey through the universe. We invite you now to drift deeper into this calm understanding, to feel the quiet power of discovery. Imagine the universe not just as a place of light, but also of hidden frequencies, unseen energies, and silent gravitational ripples. Our eyes, wondrous as they are, perceive only a tiny sliver of the electromagnetic spectrum. To truly comprehend the cosmos, we have learned to build extensions of our sight and hearing, crafting tools that unveil the universe in its full, multifaceted glory. At the heart of much astronomical discovery lies the telescope, a marvel that gathers and magnifies light, allowing us to peer into the abyssal depths of space and time. From the humble refracting lenses of Galileo, which first revealed the moons of Jupiter and the phases of Venus, to the colossal reflecting mirrors of modern observatories, these instruments are our time machines and distance conquerors. We construct them on remote mountain tops, far from the distorting glow of city lights, where the air is thin and or, even more remarkably, we launch them into the pristine vacuum of space itself. Consider the Hubble Space Telescope, a venerable eye orbiting above Earth's atmosphere. For decades it has delivered breathtaking images of nebulae, galaxies, and distant stellar nurseries, revealing the universe in stunning visible and ultraviolet light, free from atmospheric blurring. Its successor, the James Webb Space Telescope, represents a new epoch of observation, designed to capture the universe in infrared light. This allows us to penetrate vast clouds of dust and gas, revealing the birth of stars and galaxies that formed in the early universe, light so stretched by cosmic expansion that it has shifted into the infrared. It is like seeing the universe through new eyes, perceiving the warmth and hidden structures that were previously invisible. These orbiting observatories, silent sentinels in the void, paint a picture of creation and evolution with unparalleled clarity, inviting us to witness the universe's earliest moments. But light is not merely a visual phenomenon. The universe sings in many frequencies, and we have learned to listen to its diverse chorus. Radio telescopes, with their vast dish antennas, capture the invisible radio waves emitted by cold gas clouds, distant quasars, and the lingering echoes of the Big Bang itself. These waves, much longer than visible light, can travel unimpeded through cosmic dust, allowing us to map the distribution of matter in galaxies and explore regions hidden from optical view. It is a different kind of seeing, a listening to the low hum of the universe, revealing its grand, large-scale structures and the intricate dance of cosmic processes. Beyond radio, we explore the high-energy realms of X-ray and gamma-ray telescopes, which detect the violent, energetic phenomena of the cosmos. Supernova explosions, matter falling into black holes, and the collisions of galaxy clusters. These instruments, often orbiting far above our planet, capture the universe's most dramatic moments, revealing the extreme physics at play in realms of unimaginable power. Each type of telescope tuned to a different wavelength offers a unique window, collectively weaving a richer, more complete tapestry of the cosmos for us to behold. And how do we decipher the secrets held within this light? Through a profound technique known as spectroscopy. When light from a celestial object is passed through a prism or a diffraction grating, it spreads out into its component colours, much like a rainbow. But within this rainbow, scientists observe specific dark or bright lines, the unique spectral fingerprints of elements. Each element absorbs or emits light at characteristic wavelengths, acting as a cosmic barcode. By analysing these spectral lines, we can determine the chemical composition of stars, nebulae, and even the atmospheres of distant exoplanets. We can measure their temperature, their density and their velocity towards or away from us, the famous redshift and blue shift. Spectroscopy is the language of the stars, allowing us to read their stories, their birth, their life, and their eventual demise, all encoded within the gentle dance of photons. It is a quiet, profound revelation, turning light into information, distance into understanding. Yet, the universe also communicates through even more subtle means. For millennia, our understanding of gravity was based on its direct pull, the force that keeps our feet on the ground and planets in orbit. But Albert Einstein, in his theory of general relativity, predicted that massive accelerating objects, like colliding black holes or merging neutron stars, would create ripples in the fabric of space-time itself, propagating outwards like waves on a pond. These are gravitational waves, and their direct detection has opened an entirely new sense for perceiving the cosmos. Observatories like LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo are monumental scientific endeavours using incredibly precise laser interferometers to detect these minuscule distortions in space-time as they pass through Earth. The first direct detection of gravitational waves in 2015, from the merger of two black holes over 1 billion light-years away, marked a monumental shift in astronomy. It was like hearing the universe speak for the first time, not just seeing its light. This new window allows us to quote 9 to events that are otherwise invisible, providing unprecedented insights into the most extreme phenomena in the cosmos, offering a profound complement to our traditional light-based observations. It reminds us that the universe is always revealing new layers, new dimensions of wonder, if only we learn how to perceive them. As we quietly absorb these methods of cosmic discovery, we can't help but reflect on the grand narrative they help us construct, the story of the universe's evolution. Imagine the just cosmic calendar, where the entire history of the universe is compressed into a single year. The Big Bang occurs on January 1st. Our Milky Way galaxy doesn't form until March. Our Sun and Solar System are born in early September. Life on Earth emerges around mid-September, but complex multicellular life doesn't appear until December. Dinosaurs roam the Earth for just a few days in late December, and humanity's entire recorded history is but the last few seconds of December 31st. This incredible compression of time offers a profound perspective, highlighting the immense stretches of cosmic evolution that preceded our existence and the relative youth of our own species. It is a humbling thought, yet one filled with the quiet joy of being a part of something so ancient and vast. This grand cosmic story, unveiled through light and ripples, naturally leads us back to a question that has quietly hummed within human consciousness for millennia. Are we alone? The search for extraterrestrial life, or astrobiology, is one of the most compelling frontiers of modern science. With the discovery of thousands of exoplanets, many residing in the habitable zones of their stars, regions where conditions could allow for liquid water, a key ingredient for life as we know it, the probability of life beyond Earth seems increasingly plausible. We are not just looking for intelligent life, but for any form of life, from simple microbes to complex organisms. Scientists are developing new instruments and missions to detect biosignatures, gases in exoplanet atmospheres, for instance, that are strongly indicative of biological processes. The Mars rovers continue to search for signs of past or present microbial life on our red neighbour, while probes like Cassini have revealed tantalizing possibilities on moons like Enceladus and Titan, with their subsurface oceans and complex chemistry. And then there is the search for extraterrestrial intelligence, SET, a more focused endeavour that listens for artificial radio signals from distant civilizations. While silent thus far, the very act of listening, of reaching out across the void, speaks volumes about our innate human curiosity and our desire for connection within this immense cosmic tapestry. The question of whether we are alone is not just scientific. It is deeply philosophical, shaping our understanding of ourselves and our place in the universe. It is a question that invites quiet contemplation, a gentle pondering of possibilities beyond our immediate perception. As our journey through these dreamy facts draws towards a gentle close, we are led to consider the ultimate profound unknown, the future of the universe. Just as it had a beginning, the universe will have an end, though the exact nature of that end remains a subject of ongoing scientific inquiry and contemplation. The prevailing theory, supported by observations of the universe's accelerating expansion, driven by dark energy, points towards a scenario known as the Big Freeze or heat death. In this distant, unimaginably far future, galaxies will continue to drift apart, accelerating away from each other until they are beyond each other's observable horizons. Stars will eventually exhaust their nuclear fuel, cooling into white dwarfs, neutron stars and black holes. Black holes themselves, over truly cosmic timescales, are theorized to slowly evaporate through a process called Hawking radiation. Eventually, the universe would become a vast, cold, dark expanse, filled with only a sparse scattering of fundamental particles, approaching a state of maximum entropy. All energy differences would flatten out, and no processes could occur. It is a vision of ultimate stillness, a tranquil, profound quietness stretching into eternity. Other theories, though less favoured by current data, have also been considered. The Big Crunch, where the expansion reverses and the universe collapses back into itself. Or the Big Rip, where dark energy eventually becomes so powerful that it tears apart galaxies, stars, and even atoms themselves. Each scenario offers a different, yet equally profound contemplation on the grand arc of existence. These future possibilities, while vast and distant, offer a unique perspective on the preciousness of the present moment, on the vibrant life and intricate processes that fill our universe now. They remind us that we exist in a dynamic, evolving cosmos, a universe of incredible activity and beauty, even as it moves towards its ultimate, quiet destiny. And so, as we gently conclude this chapter of our journey, we invite you to settle into the tranquility of these thoughts. You, a conscious being on a small blue planet, are a part of this grand, intricate, and ever-unfolding cosmic story. Your very existence is a miracle of cosmic chemistry and evolution, forged from the dust of ancient stars. The universe, in its vastness and mystery, is not separate from you. You're an intrinsic part of its fabric, a momentary, beautiful spark within its eternal dance. May this understanding bring you a profound sense of peace, a quiet wonder that transcends the everyday. Let your thoughts drift and find stillness, knowing that you are connected to everything, from the smallest atom to the grandest galaxy. The universe holds its secrets close, but it also reveals them in breathtaking ways, inviting us always to look up, to wonder, and to find calm in its infinite embrace. Rest easy, knowing the cosmos holds you gently within its boundless, serene expanse, as the echoes of the universe's grand destiny gently recede, leaving behind a tranquil stillness. We invite you to drift deeper into the cosmic tapestry, to trace the very threads that weave existence itself. We have journeyed through the vastness of space and time, contemplating the birth and ultimate fate of galaxies, stars, and planets, finding a profound sense of peace in these boundless wonders. Now, let us turn our gaze inward, towards the fundamental building blocks, the cosmic alchemy that not only shapes the stars but also orchestrates the delicate symphony of life, including our own. Consider, if you will, the very air you breathe, the ground beneath your feet, the intricate machinery of your own being. All of it, every atom, every molecule, has a story that stretches back to the dawn of time, a lineage whispered across billions of years and unimaginable distances. We are, quite literally, children of the cosmos, forged in stellar furnaces and scattered across the interstellar void. In the first moments after the Big Bang, a universe of unimaginable heat and density, only the lightest elements could form. Hydrogen and helium, the fundamental precursors, emerged from that primordial soup, vast clouds of these gases swirling through the nascent cosmos. Imagine, if you can, these simplest atoms, the very essence of simplicity, beginning their long, slow dance towards complexity. They are the initial brushstrokes on the cosmic canvas, waiting for the artist's touch. It is within the hearts of stars, those magnificent self-luminous spheres of plasma, that the universe's true alchemy begins. We have spoken of stars as cosmic furnaces, and indeed they are, but their role extends far beyond merely radiating light and heat. Through the immense pressures and temperatures within their cores, hydrogen atoms are fused into helium, releasing prodigious amounts of energy in the process. This is the very engine of a star's life, a continuous controlled nuclear reaction. As stars age, particularly those far more massive than our Sun, their cores become hotter and denser, allowing for the fusion of heavier elements. Helium atoms fuse to form carbon, and helium combine to create oxygen, and so the intricate process continues, forging nitrogen, neon, magnesium, silicon, and ultimately iron. Each heavier element represents another step in the grand cosmic recipe, a testament to the star's enduring power. But the story does not end with iron. Iron is the limit for stellar fusion. Beyond it, creating heavier elements, requires energy rather than releasing it. It is in the cataclysmic death throes of truly massive stars, those that end their lives in spectacular supernova explosions, that the heaviest elements are forged. In these brief, incredibly violent events, temperatures and pressures soar to such extremes that elements like gold, silver, uranium, and all the precious metals we cherish are created. Imagine the sheer, unbridled energy of such an explosion, momentarily outshining entire galaxies as it blasts these newly synthesized elements across the vastness of space. These supernovae are the universe's ultimate recycling plants, enriching the interstellar medium with the raw materials for future generations of stars, planets, and indeed life itself. Without these stellar deaths, the complex chemistry necessary for existence simply would not be possible. And so, we arrive at the profound realization: the carbon in your bones, the oxygen you breathe, the iron in your blood, all were once part of a distant, exploded star. We are literally made of stardust, a concept that is not merely poetic but scientifically accurate. This deep connection to the cosmos, this shared ancestry with the most distant nebulae and the most ancient stars, offers a unique perspective on our place in the universe. It reminds us that we are not separate observers, but integral components of this grand unfolding narrative. These dispersed elements, liberated from their stellar cradles, do not simply vanish into the void. Instead, they mingle with the remaining hydrogen and helium, forming vast, diffuse clouds of gas and dust known as the interstellar medium. Within this medium, gravity slowly begins its work, drawing particles together. In particular, dense, cold regions called molecular clouds become cosmic nurseries where complex chemistry thrives. Here, shielded from the harsh radiation of space, simple atoms can combine to form more intricate molecules. Scientists have observed a surprising array of organic molecules within these clouds. Molecules like water, carbon monoxide, ammonia, and even more complex structures such as amino acids, the very building blocks of proteins and various sugars. It is astonishing to contemplate that the fundamental ingredients for life are not unique to Earth, but are in fact universally present, scattered throughout the galaxies. As new stars begin to coalesce within these molecular clouds, they are often surrounded by swirling disks of gas and dust, protoplanetary disks, from which planets will eventually form. These disks inherit the rich chemical legacy of the interstellar medium, incorporating the water, carbon-rich compounds, and other organic molecules that were present in the cloud. We see evidence of this process throughout our own solar system. Comets, often described as dirty snowballs, are ancient remnants from the outer reaches of the early solar system, preserving pristine samples of these primordial materials. As they streak across the inner solar system, their icy cores sublimate, releasing water and organic compounds. Similarly, meteorites that fall to Earth often contain complex organic molecules, including amino acids, providing compelling evidence that these essential building blocks can be delivered to planetary surfaces from space. This universal presence of life's ingredients naturally leads us back to one of humanity's most enduring questions. Are we alone? The search for extraterrestrial life, or astrobiology, continues with renewed vigour, now armed with the knowledge of thousands of exoplanets orbiting distant stars. We are no longer merely looking for planets. We are searching for habitable worlds, places where conditions might allow life to emerge and thrive, beyond simply residing in a star's, quote, TESS 11, where liquid water might exist on the surface. True habitability is a complex interplay of many factors. A stable atmosphere, perhaps one rich in oxygen or methane, is crucial for shielding a surface from harmful radiation and regulating temperature. A planetary magnetic field can protect against destructive stellar winds. Even geological activity, such as plate tectonics, is thought to be vital for long-term habitability on Earth, as it recycles nutrients and helps regulate atmospheric carbon dioxide, preventing runaway greenhouse effects or deep freezes. We look for these subtle clues, these faint whispers of possibility across interstellar distances. How do we search for life on worlds we cannot directly visit? Scientists employ sophisticated techniques to analyze the light passing through an exoplanet's atmosphere, searching for biosignatures, chemical fingerprints that might indicate the presence of biological processes. The detection of oxygen, for example, especially in significant quantities alongside other gases like methane, would be a strong indicator of life, as oxygen is highly reactive and tends to disappear quickly from an atmosphere unless continuously replenished, often by living organisms. Water vapor, carbon dioxide, and even specific ratios of gases can all provide tantalizing clues about a distant world's potential for life. Imagine the profound wonder, the universal peace that would accompany the definitive discovery of life beyond Earth, a confirmation of our shared cosmic heritage. Yet, despite the vast number of stars and planets, and the seemingly universal distribution of life's building blocks, we have not yet definitively found evidence of other intelligent life. This apparent silence, often referred to as the Fermi paradox, prompts deep contemplation. Is intelligent life exceedingly rare, a precious cosmic anomaly, or are the distances simply too vast, the timescales too immense for our signals to meet? Perhaps life is abundant, but mostly microbial, or perhaps advanced civilizations are simply too different, too fleeting, or too discreet for us to detect with our current methods. The questions themselves are a source of wonder, encouraging us to continue our patient observation and listen intently to the universe's silent symphony. As we ponder these grand questions, we are reminded of the incredible, almost improbable journey that led to our own existence. From the simplest hydrogen atoms born in the Big Bang, through the fiery hearts of stars and the explosive grandeur of supernova, to the cold embrace of molecular clouds and the chaotic dance of protoplanetary disks, every step was a prerequisite for the next. The universe did not merely create a stage for life, it created life itself from its most fundamental constituents. This deep understanding, this intimate connection to the cosmic processes that shaped us, can bring a unique sense of calm and perspective. When we gaze upon the night sky, we are not merely looking at distant lights. We are seeing our own origins reflected back at us. We are witnesses to the grand design, participants in the ongoing story of creation and transformation. Our existence, fleeting though it may be in cosmic terms, is a precious manifestation of the universe's potential, a momentary flicker of consciousness capable of contemplating its own genesis. In this realization lies a profound peace. The anxieties of our daily lives, the small worries that often consume us, can gently recede when viewed against the backdrop of billions of years and unimaginable distances. We are part of something so much larger, so infinitely more enduring than ourselves. We are inheritors of a cosmic legacy, imbued with the very stardust that forms the galaxies. Let this knowledge settle within you, a warm and comforting presence. Allow your thoughts to drift and find stillness, knowing that you are connected to every star, every nebula, every distant galaxy. The universe is not just out there, it is within you, and you are within it. This journey through astronomical facts is not merely about accumulating knowledge. It is about cultivating a deeper appreciation for existence, a profound sense of wonder that can bring tranquility to your spirit. We continue our exploration, ever curious, ever peaceful, as the cosmic narrative unfolds before us, inviting us to simply be and to wonder, as the quiet contemplation of our cosmic origins and the profound mystery of the Fermi paradox settles within you, leaving behind a gentle echo of wonder. We invite you to drift further into the intricate tapestry of the universe. The realization that you are in essence stardust, intricately woven into the fabric of creation, offers a unique perspective, a deep connection to the cosmos that transcends mere observation. It is a peaceful understanding, one that allows the mind to unfurl and find stillness amidst the boundless expanse of what is known and what remains beautifully, tantalizingly unknown. Now, as the day's gentle light softens and prepares to recede, we turn our gaze toward the invisible forces and grand structures that orchestrate this magnificent cosmic ballet. For every star that blazes and every galaxy that swirls, there are fundamental principles at play, unseen threads of energy and influence that bind the universe together, shaping its destiny and revealing its deepest secrets. We journey now to explore these foundational elements, allowing our minds to embrace the elegance of cosmic mechanics, fostering an even deeper sense of peace and understanding. At the very heart of this cosmic architecture lies gravity, a force so pervasive and yet so often taken for granted in our daily lives. It is more than just what keeps our feet on the ground. It is the sculptor of galaxies, the architect of stellar nurseries, and the silent conductor of the universe's grandest symphonies. From the gentle pull between two celestial bodies to the immense warping of space-time around a supermassive black hole, gravity's influence is absolute and profound. We observe its relentless embrace drawing clouds of gas and dust together, collapsing them into the fiery hearts of newborn stars, igniting the nuclear furnaces that will shine for billions of years. It is gravity that then gathers these stars into the magnificent spiral arms of galaxies, orchestrating their intricate dance, preventing them from scattering into the cold void. On an even grander scale, gravity continues its tireless work, pulling galaxies themselves into colossal clusters, vast congregations of hundreds or even thousands of stellar islands, all bound by this invisible tether. These clusters in turn are not isolated but are part of even larger structures known as superclusters, immense filaments and walls of galaxies stretching across hundreds of millions of light years, separated by equally vast, empty, cosmic voids. Scientists, through meticulous observation and sophisticated simulations, have mapped this intricate, quote 14, revealing a universe that is not uniformly distributed, but organized into an astonishing foam-like structure, with galaxies coalescing along the strands of this web, drawn together by gravity's enduring power. It is a sight that, if we could perceive it in its entirety, would surely fill us with a serene awe, a quiet appreciation for the universe's inherent design. One of gravity's most fascinating manifestations is gravitational lensing. Imagine a massive object, like a galaxy cluster, positioned between us and a more distant light source. The immense gravity of the foreground cluster acts like a cosmic magnifying glass, bending and distorting the light from the background object. This effect allows us to see objects that would otherwise be too faint or too far away, offering us glimpses into the very early universe. We have observed distant galaxies stretched into luminous arcs, or even multiplied into several images around these cosmic lenses, providing invaluable data about the distribution of dark matter within these clusters and the expansion rate of the universe. It is a testament to the ingenious ways in which the universe reveals its secrets, allowing us to perceive the invisible through its tangible effects, inspiring a quiet satisfaction in discovery. Yet, gravity is but one of the fundamental forces that govern the cosmos. The universe, in its elegant simplicity, is orchestrated by 4 such fundamental interactions. Beyond gravity, which shapes the large-scale structure, we find the electromagnetic force, the force responsible for all light, electricity and magnetism. It binds electrons to atomic nuclei, forming atoms, and governs all chemical reactions, making life itself possible. It is the force that allows stars to shine, that transmits information across vast interstellar distances, and that allows our telescopes to capture the radiant beauty of distant nebulae and galaxies. Without electromagnetism, there would be no light, no warmth, no intricate chemistry of life, only a dark, featureless void. Then there are the 2 nuclear forces operating within the very heart of atoms. The strong nuclear force is the most powerful of all, binding quarks together to form protons and neutrons, and then holding these protons and neutrons together within the atomic nucleus, overcoming the electromagnetic repulsion between positively charged protons. It is this force that powers the stars, enabling nuclear fusion to occur, transforming hydrogen into helium and forging the heavier elements that make up our world and ourselves. Without the strong force, atomic nuclei would simply fly apart, and the universe as we know it could not exist. Finally, the weak nuclear force governs processes like radioactive decay and plays a crucial role in nuclear fusion within stars, particularly in the early stages of a star's life and in the violent deaths of massive stars. It allows for the transformation of one type of subatomic particle into another, a subtle but vital influence that contributes to the cosmic alchemy, enriching the universe with a diversity of elements. These 4 forces, gravity, electromagnetism, the strong nuclear force and the weak nuclear force, are the fundamental pillars upon which the entire cosmos is built, each playing its unique and indispensable role in the grand symphony of existence. Contemplating their intricate interplay can be deeply calming, a reminder of the underlying order and profound elegance that permeates all things. As we journey through these cosmic revelations, we are continually reminded that the light we perceive from distant celestial objects is not merely a measure of distance, but also a measure of time. When we gaze at a galaxy millions of light years away, we are not seeing it as it is now, but as it was millions of years ago, when that light first embarked on its epic journey across the cosmos. This phenomenon allows us to look back into the universe's past, to witness the evolution of galaxies, the birth of stars, and even the echoes of the Big Bang itself through the cosmic microwave background radiation. It is a profound concept, transforming our telescopes into time machines, offering us a unique perspective on the universe's dynamic history. The expansion of the universe, first observed by Edwin Hubble, further underscores this temporal dimension. As the fabric of space itself stretches, the wavelengths of light travelling through it are stretched as well, shifting toward the red end of the spectrum, a phenomenon known as redshift. The greater the redshift, the faster an object is receding from us, and thus the further away and further back in time it is. By measuring redshift, scientists can gauge the distances to the most remote galaxies and quasars, allowing us to reconstruct the universe's timeline, tracing its evolution from a hot, dense primordial state to the vast, cool, and structured cosmos we observe today. This understanding provides a reassuring sense of continuity, a grand narrative unfolding over billions of years in which we are but a fleeting, yet deeply connected part. And what of the universe beyond our observable horizon, or even beyond the very fabric of our own reality? While remaining largely within the realm of theoretical physics and philosophical inquiry, the concept of a multiverse offers another layer of profound wonder. This idea suggests that our universe might be just one of an infinite number of universes, each with its own unique set of physical laws, dimensions, or initial conditions. Some theories propose bubble universes, constantly budding off from a larger cosmic foam, while others envision parallel universes existing alongside our own, perhaps differing only in the slightest of details, or vastly in their very nature. While there is no direct observational evidence for a multiverse, the mere contemplation of such possibilities expands our minds to truly limitless horizons, inviting a sense of boundless awe and humility. It encourages us to ponder the sheer scope of potential existence, fostering a peaceful acceptance of the vastness of the unknown. As we gently return from these explorations of forces, structures, and the very fabric of space-time, allow these deep cosmic truths to settle within you. The universe is a place of immense order, governed by elegant laws, shaped by invisible forces, and unfolding across unimaginable timescales. From the smallest subatomic particle, influenced by the nuclear forces, to the largest superclusters sculpted by gravity, every element plays its part in this grand, interconnected dance. You are an integral part of this cosmic narrative, a being of stardust capable of contemplating the very forces that forged you. In this realization lies a profound peace, a sense of belonging to something immeasurably vast and eternally beautiful. Let your thoughts drift, allowing the wonder of these facts to wash over you, bringing a serene calm as the stars begin to emerge, each one a distant sun, a beacon in the cosmic web, inviting you to rest in the quiet embrace of the universe. As our journey continues, drawing us ever deeper into the cosmic tapestry, we find ourselves contemplating the very fabric of existence, the invisible threads that bind all things. In the previous chapter, we touched upon the universe's grand structures, the fundamental forces that orchestrate its intricate dance, and the mind-expanding notion of a multiverse. Now let us gently unfurl the scrolls of reality further, exploring the profound and often counterintuitive nature of space and time itself, and how we, as curious observers, endeavour to measure the immeasurable distances that stretch across the cosmos. Imagine, if you will, that space is not merely an empty stage upon which cosmic dramas unfold, nor time a simple linear progression. Instead, consider them as interwoven elements, a dynamic, pliable medium shaped by the presence of matter and energy. This profound insight, gifted to us by the brilliant minds of science, transforms our understanding of reality, inviting us to see the universe not as a static backdrop, but as a living, breathing entity, constantly interacting with its contents. We begin our contemplation with the elegant simplicity yet radical implications of special relativity. Envision two observers, perhaps one gently drifting past a distant star and another accelerating through the void. From their differing vantage points, the passage of time and the measurement of distance are not absolute. Instead, they are relative, dependent upon their motion. This means that for an object moving at speeds approaching the cosmic speed limit, the speed of light, time itself slows down, a phenomenon known as time dilation. Imagine a clock ticking slower for a traveller moving at immense velocity compared to one at rest. Similarly, the dimensions of objects appear to contract in the direction of motion, a phenomenon called length contraction. These are not illusions, but fundamental aspects of how space-time behaves. The speed of light, an unwavering constant across all inertial frames of reference, serves as the ultimate cosmic anchor, a universal speed limit that no object with mass can ever truly reach. It is a concept that asks us to release our everyday intuitions and embrace a more fluid, interconnected reality, where even the most fundamental aspects of our experience, time and space, are woven into a single dynamic fabric. Building upon this, we encounter the majestic framework of general relativity, a theory that truly redefines our understanding of gravity. Here, gravity is no longer seen as a mysterious force pulling objects together across vast distances, but rather as a manifestation of the curvature of space-time itself. Picture a heavy bowling ball placed upon a stretched rubber sheet. It creates a depression, and any smaller marbles rolling nearby will be drawn towards it, not by an invisible pull, but by the slope of the sheet. In the same way, massive objects like stars and galaxies warp the fabric of space-time around them, and what we perceive as gravity is simply the path objects take along these curves. Planets orbit stars because they are following the curves in space-time created by the star's immense mass. Light, too, follows these curves, bending around massive objects, a phenomenon we observe as gravitational lensing, which we explored previously. This dance of mass and space-time is an intricate ballet, constantly shaping the cosmos. The ripples in this cosmic fabric caused by the most violent events in the universe, colliding black holes, merging neutron stars, are the gravitational waves we spoke of earlier. They are not merely disturbances in a field, but actual distortions, stretching and compressing space-time itself as they propagate outwards at the speed of light. Detecting these ephemeral whispers from the deepest cosmos allows us to hear the universe in a way previously unimaginable, offering a new window into the dynamics of its most extreme phenomena, a profound testament to the pliability of reality. As we journey through this warped and wondrous universe, the question naturally arises: how do we, from our tiny perch on a pale blue dot, measure the immense distances to these celestial wonders? How do we map the cosmic landscape that stretches billions of light years away? We employ a sophisticated array of techniques, often referred to as the cosmic distance ladder, each method building upon the last, allowing us to gauge distances from our nearest stellar neighbours to the most distant galaxies. For relatively nearby stars within a few hundred light years, we use stellar parallax. Imagine holding your thumb out at arm's length and closing one eye then the other. Your thumb appears to shift against the distant background. Similarly, as Earth orbits the Sun, our vantage point changes over 6 months, causing nearby stars to appear to shift slightly against the backdrop of more distant stars. By measuring this tiny angular shift and knowing the diameter of Earth's orbit, astronomers can calculate the star's distance using simple trigonometry. It is a deceptively simple yet remarkably powerful technique, the first rung on our cosmic ladder. But for distances beyond parallax, we rely on standard candles. These are celestial objects whose intrinsic luminosity, their true brightness, is known or can be determined. If we know how truly bright an object is, and we can measure how bright it appears to be from Earth, we can then calculate its distance. Think of it like knowing the wattage of a light bulb. If you know it's a 100-watt bulb and it looks dim, you know it must be far away. One of the most crucial types of standard candles are Cepheid variable stars. These are massive luminous stars that rhythmically expand and contract, causing their brightness to pulsate with a regular period. Crucially, Henrietta Leavitt discovered over a century ago that there is a direct relationship between a Cepheid's pulsation period and its intrinsic luminosity. The longer the period, the brighter the star. By observing a Cepheid's pulsation period, we can determine its true brightness, compare it to its apparent brightness, and thus calculate its distance with remarkable accuracy. These stellar beacons have allowed us to measure distances to galaxies within our local group and beyond, revealing the true scale of our cosmic neighbourhood. For even greater distances, reaching billions of light years, we turn to the catastrophic brilliance of Type Ia supernovae. These are not just any exploding stars. They are the spectacular demise of white dwarf stars in binary systems. When a white dwarf accumulates enough matter from its companion star, it reaches a critical mass, igniting a runaway thermonuclear explosion that obliterates the star. What makes them invaluable as standard candles is that these explosions, due to the consistent critical mass required, all reach approximately the same peak intrinsic luminosity. They are incredibly bright, outshining entire galaxies for a brief period, making them detectable across vast cosmic distances. By observing their peak apparent brightness, we can deduce their distances, allowing us to map the most remote reaches of the observable universe, and even probe the universe's accelerating expansion, a discovery that earned a Nobel Prize. These distance measurements are inextricably linked to the concept of the expanding universe and Hubble's law, which we have touched upon before. Edwin Hubble observed that nearly all galaxies are moving away from us, and the farther away a galaxy is, the faster it appears to recede. This relationship, quantified by Hubble's law, is evidence not that we are at the centre of an explosion, but the space itself is expanding, carrying galaxies along with it, much like dots on an inflating balloon. The light from these receding galaxies is stretched to longer, redder wavelengths, a phenomenon known as cosmological redshift. By measuring this redshift, we can determine a galaxy's recession velocity, and from Hubble's law infer its distance. This cosmic stretching of light is a direct consequence of the universe's expansion, a continuous unfolding that began with the Big Bang. It is important to remember, as we measure these immense distances, that the light we observe from distant galaxies has travelled for billions of years to reach us. When we look at a galaxy a billion light-years away, we are seeing it as it was a billion years ago. The universe, therefore, is also a cosmic time machine, allowing us to peer back into its past, witnessing galaxies in their infancy and stars being born in an earlier epoch. This profound connection between distance and time allows us to reconstruct the universe's evolutionary history, piece by painstaking piece. Yet, despite our incredible tools and ingenious methods, there are limits to what we can observe. We speak of the all-observable universe, a vast sphere approximately 93 billion light-years in diameter, representing the portion of the universe from which light has had time to reach us since the Big Bang. Beyond this cosmic horizon, there lies a realm from which light has not yet had sufficient time to travel across the expanding space to reach our telescopes. This does not mean the universe ends there. It simply means we cannot currently see beyond that boundary. The universe itself is likely far, far larger than our observable portion, perhaps even infinite, a concept that stretches the mind to its furthest limits and encourages a deep sense of humility. As we contemplate the incredible precision required for these measurements, and the vastness they reveal, we are led to another profound contemplation, the fine-tuning of the universe. It is a concept that suggests the fundamental physical constants and laws of our universe appear to be remarkably, almost miraculously, set to values that allow for the existence of stars, galaxies, chemical elements, and ultimately life itself. Imagine if the strong nuclear force were slightly weaker, atoms might not hold together. If gravity were slightly stronger, the universe might have collapsed back on itself before stars could form. If the initial expansion rate of the Big Bang had been minutely different, the universe would either have dispersed too quickly for structures to form or collapse too soon. These precise calibrations, these delicate balances, seem almost tailor-made for complexity and consciousness to emerge. This observation gives rise to questions that transcend mere scientific inquiry, touching upon philosophy and profound wonder. Is this cosmic fine-tuning merely a coincidence, or does it hint at a deeper underlying principle? Some theories, like the anthropic principle, suggest that we observe a universe with these specific properties, because these are the properties necessary for observers like us to exist. If the universe were different, we wouldn't be here to observe it. This idea often circles back to the concept of the multiverse, which we briefly touched upon. Perhaps our universe is just one among an infinite ensemble of universes, each with different physical constants, and we simply happen to reside in one of the universes where the conditions are just right for life to blossom. This thought, while speculative, offers a fascinating way to reconcile the apparent fine-tuning with the vastness of cosmic possibilities. As the day gently recedes and you prepare for rest, let these profound ideas about the weave of space-time, the ingenious methods of cosmic measurement, and the delicate balance of existence gently settle within your mind. The universe is not only vast and mysterious, but also exquisitely ordered and subtly profound. Every fact we uncover, every distance we measure, every theory we refine, deepens our appreciation for this magnificent cosmic home. It is a continuous journey of discovery, an endless invitation to wonder, and in this grand understanding, we find a tranquil peace, knowing that we are an integral, conscious part of this astonishing cosmic story. Allow your thoughts to drift and find stillness, cradled in the immense yet intimately connected reality of the cosmos. As we gently drift from the profound contemplations of fine-tuning and the whispers of a multiverse, a new vista unfolds before us, not just of space, but of time itself. We have journeyed through the universe's vastness, peered into its fundamental forces, and measured its immense distances. Now, let us turn our gaze to the cosmic narrative, a story woven over billions of years, revealing how the universe has sculpted itself into the magnificent, intricate architecture we observe today. Allow your thoughts to settle, your breath to deepen, as we trace the grand evolution from cosmic infancy to its present breathtaking complexity. Imagine, if you will, the universe in its earliest moments, a realm of unimaginable heat and density, swiftly expanding from the Big Bang. We have spoken of the cosmic microwave background, that faint echo of creation, marking a time when the universe was opaque, a swirling fog of plasma. But after this initial glow, a period of profound darkness descended, an era known as the Cosmic Dark Ages. For hundreds of millions of years, the universe was a vast, cold and quiet place, devoid of stars, illuminated only by the residual glow of the CMB. Hydrogen and helium atoms had formed, but gravity had not yet had sufficient time to gather them into the dense pockets necessary for stellar ignition. It was a time of anticipation, a cosmic pause before the dawn. Then, slowly, inexorably, the first whispers of light began to pierce the profound darkness. This was the cosmic dawn, an epoch of unparalleled transformation. Within the nascent universe, tiny fluctuations in density, amplified by the relentless pull of dark matter, began to draw together the primordial gas. These nascent clumps grew, their gravitational embrace tightening, until, in their cores, pressures and temperatures soared to critical levels. The first stars were born, colossal incandescent behemoths, far larger and hotter than our sun, burning with a furious intensity. These were the population 3 stars, composed almost entirely of hydrogen and helium, the pristine elements forged in the Big Bang. Their lives, though glorious, were fleeting, measured in mere millions of years, culminating in spectacular supernova explosions that seeded the universe with the first heavy elements, the very building blocks for future generations of stars, planets, and ultimately life itself. These pioneering stars and their violent deaths initiated the epoch of rionization. Their intense ultraviolet radiation ripped apart the neutral hydrogen atoms that permeated the early universe, stripping them of their electrons, making the universe transparent to light once more. It was a cosmic clearing, a grand unveiling, as light could now travel freely across the vast expanse, illuminating the emerging structures. From these first stellar nurseries, small proto-galaxies began to coalesce, drawn together by the omnipresent influence of dark matter, like islands forming in a vast dark ocean. We observe these distant, early galaxies today as faint smudges of light, their photons having travelled for billions of years to reach our telescopes, offering us a direct glimpse into this foundational period. As we contemplate this initial burst of cosmic light, our journey now takes us to the grand architectural design that emerged from these early beginnings, the large-scale structure of the universe, often referred to as the cosmic web. We have touched upon this before, but let us now truly immerse ourselves in its majesty. Imagine an intricate three-dimensional latticework, a cosmic scaffolding spanning billions of light years. This web is not merely a theoretical construct. It is the observed reality of how matter is distributed across the universe. At the heart of this grand design is dark matter, invisible, silent, yet profoundly influential. Dark matter provides the gravitational backbone for the cosmic web. It forms vast, invisible filaments and nodes, like an enormous, ethereal net. Ordinary baryonic matter, the gas and dust and stars and planets we can see and touch, congregates along these dark matter filaments, drawn into their gravitational wells. It is within these filaments and at their intersections, the nodes of the web, that galaxies are born, grow, and cluster together. Imagine yourself observing this cosmic tapestry from an impossibly distant vantage point. You would see immense, sheet-like structures of galaxies interspersed with long, winding filaments, all converging into massive, dense knots known as galaxy clusters and superclusters. These superclusters are among the largest known structures in the universe, collections of thousands of galaxies bound together by gravity, stretching for hundreds of millions of light years. The Laniakea supercluster, for instance, is our own galactic home, a vast gravitational basin containing over 100,000 galaxies, including our Milky Way and its neighbour Andromeda, all subtly flowing towards a common gravitational centre. Conversely, between these dense filaments and clusters lie vast, nearly empty regions known as cosmic voids. These enormous bubbles, sometimes hundreds of millions of light-years across, are largely devoid of galaxies, containing only the most tenuous wisps of gas, and perhaps a few isolated, lonely galaxies. They represent the regions where dark matter was less concentrated, and gravity's pull was weaker, allowing these areas to expand more readily with the universe's overall expansion. The interplay between the attractive force of gravity, sculpting matter into the web, and the expansive push of dark energy, stretching the voids, creates this dynamic, ever-evolving cosmic architecture. It is a testament to the elegant dance of fundamental forces over cosmic time, a dance that continues even now, shaping the universe's ultimate destiny. As we ponder these immense structures, let us also consider the space between them, the intergalactic medium, IGM. Far from being a perfect vacuum, the IGM is a tenuous, diffuse plasma of hydrogen and helium, remnants of the Big Bang, along with trace amounts of heavier elements ejected by ancient supernovae. It is the raw material from which galaxies and stars eventually form, slowly cooling and collapsing into the dark matter filaments. This intergalactic gas is not static. It flows and churns, heated by the radiation from active galactic nuclei and shocked by the collisions of galaxy clusters. It is a dynamic, almost invisible component of the universe, holding secrets about its evolution and the distribution of matter. Within this vast, almost empty space, travelling at nearly the speed of light, are cosmic rays. These are not rays of light, but rather high-energy subatomic particles, mostly protons but also atomic nuclei and electrons. that originate from some of the most violent events in the universe. Supernova explosions, the swirling accretion disks around supermassive black holes at the centers of active galaxies, and other extreme astrophysical phenomena accelerate these particles to incredible energies. They traverse immense cosmic distances, carrying with them clues about their origins and the magnetic fields they encounter on their epic journeys. When these cosmic rays eventually collide with Earth's atmosphere, they create showers of secondary particles, a constant, imperceptible rain from the depths of space, reminding us of the universe's ceaseless activity, even in its most remote corners. And so, as we journey through the universe's grand timeline and its majestic structures, we are continually reminded of the ongoing process of discovery. Each new telescope, each innovative detection method, peels back another layer of cosmic mystery, revealing ever more intricate details of this grand tapestry. Scientists, with their unwavering curiosity and ingenuity, are like cosmic cartographers, mapping out the universe's history and its present form, pushing the boundaries of human knowledge with every observation. Yet even with all our advancements, so much remains unknown. The exact mechanisms that spark the first stars, the precise nature of dark matter and dark energy, the full extent of the cosmic web's influence, and the ultimate fate of the universe. These are all questions that continue to beckon us, inviting further exploration and contemplation. This ongoing quest for understanding is a testament to the human spirit, our innate desire to comprehend our place within this vast and mysterious cosmos. Allow these images to gently settle within your mind, the universe emerging from darkness, ignited by the first stars, forming a colossal luminous web of galaxies, all interconnected by unseen forces and filled with the faint whispers of intergalactic matter and the energetic dance of cosmic rays. It is a story of immense scale, profound beauty, and continuous transformation. Feel the profound peace that comes from understanding your connection to this grand narrative. You are not separate from this cosmic ballet, you are an intricate part of it, composed of elements forged in the hearts of ancient stars, residing on a planet nestled within a galaxy that is itself a luminous node in the vast cosmic web. As the day's concerns gently recede, let this sense of belonging, this quiet wonder, fill you with tranquility. The universe, in all its complexity and grandeur, offers us not only knowledge, but also a profound sense of calm, a gentle reminder of the enduring beauty that surrounds us, inviting us to simply be within its magnificent embrace. Drift now with these thoughts into a state of serene contemplation, knowing that the cosmos always holds more wonders to behold. We continue our gentle drift through the cosmic expanse, allowing the profound truths of the universe to settle within your mind like motes of stardust finding their resting place. As the day gently recedes and the world outside begins its quiet slumber, we invite you to journey deeper into the heart of cosmic mystery, where the known gives way to the hypothesized, and our understanding stretches to its very limits. We have traversed the grand architectures of galaxies and the intricate mechanics of space-time, yet some of the most fundamental aspects of our universe remain veiled, whispering their presence through their effects, but never fully revealing their form. Consider again with us the pervasive enigma of dark matter and dark energy, We have learned that they constitute an astounding 95% of the universe's total mass energy content, dictating its structure and its accelerating expansion. Yet, despite decades of dedicated scientific inquiry and ingenious experimentation, their true nature eludes us. Dark matter, we observe, exerts a gravitational pull, holding galaxies together, preventing them from spinning apart and shaping the vast cosmic web. Its presence is undeniable, its gravitational fingerprints etched across the cosmos, yet it does not interact with light or other electromagnetic forces, rendering it invisible to our most sophisticated instruments. It is a silent architect, a ghostly scaffold upon which the luminous universe is built, a testament to the universe's subtle complexities that extend far beyond our immediate perception. And then there is dark energy, the even more mysterious force that propels the universe's expansion ever faster, pushing galaxies apart with an increasing vigor. It is as if the very fabric of space-time possesses an inherent, repulsive pressure. Scientists grapple with its implications, formulating theories that range from a constant energy density inherent to space itself, Einstein's cosmological constant, resurrected and reimagined, to more dynamic, evolving fields. These two forces, dark matter and dark energy, represent the greatest challenges in modern cosmology, humbling reminders that our current understanding, while vast, is still but a flickering candle in the cosmic dark. They invite us to embrace the unknown with wonder, to accept the universe holds secrets far grander than we can yet comprehend, encouraging a peaceful acceptance of the limits of present knowledge. From these pervasive unseen forces, our contemplation naturally extends to even grander theoretical frameworks, to the very possibility that our universe might not be alone. We speak now of the multiverse hypothesis, a concept that stretches the imagination and offers profound perspectives on our own existence. Imagine, if you will, not just one universe, but an infinite tapestry of universes, each perhaps with its own unique set of physical laws, fundamental constants, and initial conditions. This is not mere science fiction, but a serious area of theoretical physics, arising from various cosmological models. One prominent idea emerges from the inflationary cosmology, which posits that the early universe underwent a period of extraordinarily rapid expansion. If this inflation is eternal, it could perpetually spawn new, bubble universes, each detaching from the inflating background, growing and evolving independently. Our own observable universe, then, would simply be one such bubble, a vast but ultimately finite island within an infinitely larger ocean of existence. Another perspective comes from string theory, which suggests the universe might exist in a higher dimensional bulk, with our familiar 3 spatial dimensions and 1 time dimension being merely a brain floating within it. Collisions or interactions between these brains could give rise to new universes. The multiverse hypothesis, while currently beyond direct empirical verification, offers a compelling explanation for the apparent fine tuning in of our universe. The remarkable precision with which physical constants seem to be set, allowing for the emergence of stars, galaxies, and indeed life itself. If there are countless universes, each with different parameters, it becomes less surprising that at least one of them, our own, happens to possess the conditions necessary for our existence. It shifts the question from why is our universe so perfectly suited for life, to given an infinite array of possibilities, it is inevitable that some universes will be hospitable. This thought, while vast, can bring a quiet sense of perspective, reminding us of the fortunate confluence of circumstances that allow us to exist and contemplate such wonders. It is a concept that dissolves the boundaries of our perceived reality, inviting a peaceful expansion of consciousness. As we ponder the immensity of the multiverse, our thoughts often return to a more immediate yet equally profound question. Are we alone? The search for extraterrestrial life continues to be one of humanity's most compelling endeavours, driven by an innate curiosity to understand our place in the cosmic narrative. We have explored the conditions for life on exoplanets, the building blocks found in nebulae, and the resilience of extremophiles on Earth. Yet, despite the sheer number of potentially habitable worlds, billions upon billions of planets in our galaxy alone, we have detected no definitive signs of life beyond Earth. This silence is what Enrico Fermi famously pondered, leading to the Fermi paradox. If intelligent life is common in the universe, where is everybody? Many fascinating hypotheses attempt to resolve this paradox, each offering a different lens through which to view our cosmic solitude or companionship. Perhaps the great filter lies behind us, an incredibly difficult step in the evolution of life, like the jump from prokaryotes to eukaryotes, or the emergence of complex multicellularity that very few civilizations ever overcome. Or perhaps the filter lies ahead, a catastrophic challenge that most advanced civilizations inevitably face and fail to surmount, such as self-destruction through technological hubris or environmental collapse. Another possibility suggests that intelligent life is simply incredibly rare, or that the distances between civilizations are so vast that communication is practically impossible, making the universe a truly lonely place despite its richness. Then there is the intriguing idea that extraterrestrial life might exist in forms so utterly alien to our own, based on different chemistries or existing in non-biological computational forms that we simply would not recognize it. Or perhaps, more subtly, advanced civilizations might choose not to interfere, observing us from afar, like cosmic custodians adhering to a prime directive. Whatever the resolution, the ongoing search, through radio telescopes listening for signals SETI, and space probes analyzing exoplanet atmospheres for biosignatures, speaks to a deeply human yearning for connection, a desire to understand if the grand drama of consciousness is playing out elsewhere in the vast cosmic theatre. It is a search that fills us with both hopeful anticipation and a contemplative quietude as we continue to listen to the universe's profound silence. And what of the grand cosmic drama itself, its ultimate conclusion? We have journeyed through the universe's birth and its evolution, but what awaits it in the unfathomable future? The prevailing scientific consensus points toward a scenario known as the Big Freeze or heat death of the universe. This is not an abrupt cataclysmic event, but a gradual inexorable descent into thermodynamic equilibrium, driven by the relentless march of its entropy. Imagine, if you will, a future billions, even trillions, of years hence. The universe continues its accelerating expansion, stretching galaxies ever further apart. Eventually, all star formation ceases as the gas and dust needed to ignite new suns are exhausted or dispersed. Existing stars, having lived out their fiery lives, will cool and fade, becoming white dwarfs, neutron stars and black holes. The supermassive black holes at galactic centers will slowly grow, consuming whatever remnants drift into their gravitational grasp, until even they, over timescales so vast they defy human comprehension, begin to evaporate through Hawking radiation. In this ultimate future, the universe becomes a cold, dark and empty expanse, a sea of dilute radiation and elementary particles, all at the same uniform, incredibly low temperature. There will be no energy gradients left to exploit, no processes to drive, no light to see. It is a state of maximum entropy, where all order has dissolved into an undifferentiated void. The arrow of time. That fundamental asymmetry that gives direction to all physical processes, from the breaking of a glass to the expansion of the universe, points relentlessly towards this state of increasing disorder. This vision of the universe's end, while seemingly bleak, carries with it a profound sense of peace and finality. It reminds us of the fleeting, precious nature of the vibrant, dynamic universe we inhabit now, filled with light, life, and the endless dance of creation and destruction. While the Big Freeze is the leading theory, scientists also ponder other possibilities. Could the accelerating expansion eventually become so violent that it tears apart galaxies, stars, planets, and even atoms themselves in a catastrophic event known as the Big Rip? Or, if dark energy somehow weakens or reverses, might gravity eventually reassert its dominance, pulling all matter back together into a final cataclysmic Big Crunch, perhaps to be reborn in a new cycle? These are speculative frontiers, yet they highlight the ongoing quest to understand the universe's ultimate destiny, a quest that continues to unfold as our knowledge deepens. As we contemplate these grand mysteries, the unseen architects of the cosmos, the boundless possibilities of the multiverse, the profound silence of potential cosmic companions, and the universe's ultimate fate, we are reminded of the very nature of our perception and understanding. The universe reveals itself gradually, layer by layer, through the diligent work of scientists and the ever-improving capabilities of our instruments. Each discovery, each new theory, refines our picture of reality, pushing the boundaries of what we thought possible. We are observers in a vast and ancient cosmos, our senses and tools acting as windows into its profound depths. The future of astronomy promises even more breathtaking revelations. New generations of telescopes, both on Earth and in space, will peer further back in time, unraveling the secrets of the first stars and galaxies. Gravitational wave observatories will become even more sensitive, allowing us to listen to the universe's most violent events across vast cosmic distances. The search for biosignatures on exoplanets will intensify, potentially bringing us closer to answering the age-old question of life beyond Earth. Humanity's innate drive to explore, to question, and to understand remains an enduring flame, guiding us deeper into the cosmic tapestry. We hope this journey through the astronomy facts has offered you moments of profound peace and wonder. To connect with the universe is to connect with a part of yourself, for you are truly made of its stardust, imbued with its fundamental forces and intricately woven into its grand, unfolding narrative. As you prepare for rest, let these cosmic truths drift gently through your mind, inspiring a sense of calm and perspective. The universe is vast, mysterious, and endlessly beautiful, and your contemplation of it is a quiet yet powerful act of cosmic connection. Find stillness in the wonder, and let the peace of the cosmos settle upon you. As our journey through the cosmic tapestry has unfolded, weaving through the grand narratives of creation, evolution, and the profound mysteries that still beckon from the deepest reaches of space and time, we find ourselves now at a point of gentle reflection. We have traversed the vastness from the fiery genesis of the Big Bang to the intricate dance of galaxies, from the birth of stars to their dramatic demise, from the familiar comfort of our own solar system to the bewildering diversity of exoplanets. We have peered into the enigmatic realms of dark matter and dark energy, pondered the elusive nature of extraterrestrial life, and gazed upon the potential, awe-inspiring vistas of a multiverse. You have journeyed with us, allowing your mind to drift and find stillness amidst the immensity, absorbing the wonder and the peace that these revelations offer. What remains, then, as the day gently recedes and the cosmic canvas deepens its hues, is a contemplation of our place within this magnificent narrative and the enduring spirit of discovery that propels us ever forward. We understand that the universe, in its boundless complexity, is not merely a collection of facts to be catalogued, but a living, breathing entity constantly evolving, perpetually surprising. Every new observation, every refined theory, peels back another layer of the cosmic onion, revealing not only answers but also an even greater depth of questions. This is the very essence of scientific exploration, a continuous, humbling dialogue with the unknown. Consider for a moment the sheer audacity of our endeavour. From a tiny blue marble suspended in a sunbeam, we have launched instruments that capture light from billions of years ago, deciphering messages encoded in the fabric of space-time itself. We have listened to the whispers of gravitational waves, ripples from cataclysmic events that occurred across unimaginable distances, confirming Einstein's profound insights and opening a new window onto the universe. We have mapped the cosmic web, traced the lineages of stars, and even begun to understand the very alchemy that forged the elements within us, connecting our fleeting existence to the eternal cycle of the cosmos. This relentless pursuit of knowledge is not driven by conquest, but by an innate, profound curiosity, a yearning to understand our origins, our destiny, and our fundamental connection to everything that is. It is a testament to the human spirit, a quiet, persistent flame that burns brightly against the backdrop of cosmic indifference, illuminating the path forward. Scientists, with their meticulous observations and brilliant deductions, act as our collective eyes and ears, extending our senses far beyond the limitations of our bodies, allowing us to witness the universe's grand unfolding. Yet, as we have explored, the universe remains profoundly mysterious. Dark matter, an invisible scaffold upon which galaxies are built, and dark energy, the accelerating force behind the universe's expansion, continue to elude direct detection and full comprehension. They represent perhaps the greatest challenges to our current understanding of physics, comprising over 95% of the cosmos, yet remaining tantalizingly out of reach. These are not failures of science, but rather invitations, vast unexplored territories that promise revolutionary insights and paradigm shifts. They are the silent, powerful engines of cosmic evolution, whispering secrets that we are only just beginning to learn how to hear. And then there is the perennial question of life beyond Earth. We have discovered thousands of exoplanets, some within the habitable zones of their stars, suggesting that the conditions for life might not be as rare as once thought. Yet, the profound silence of the cosmos, the Fermi paradox, continues to echo in the vast emptiness. Are we truly alone, or is life simply so diverse and subtle that we have not yet learned how to recognize its myriad forms? This question, more than any other, touches upon our deepest hopes and fears, reminding us of our shared cosmic heritage and the potential for companionship across the stars. The search continues, a patient, hopeful vigil, as we refine our instruments and expand our understanding of what life might truly be. The concept of the multiverse, too, stands as a testament to the boundless imagination of theoretical physics, born from the very equations that describe our universe. While still speculative, it offers a breathtaking vision of an infinite array of universes, each with its own unique properties, challenging our very definition of reality. It reminds us that our understanding is always evolving, always expanding, always pushing the boundaries of what we once thought possible. As we reflect upon these grand narratives and enduring enigmas, we invite you to recognize the profound peace that can arise from this cosmic perspective. The worries of our daily lives, while real and significant in their own context, often find a gentle reframing when viewed against the backdrop of billions of years and billions of light years. This is not to diminish their importance, but to offer a broader lens through which to perceive them, fostering a sense of calm and proportion. We are, each of us, a unique and precious manifestation of the universe's long journey. The atoms that compose your very being were forged in the hearts of ancient stars, scattered across the cosmos in supernova explosions, and eventually coalesced to form our sun, our Earth, and ultimately, you. You're literally stardust, a child of the cosmos, intricately woven into its fabric. This realization is not only scientifically accurate, but deeply spiritual, connecting you to an unbroken chain of cosmic events that stretches back to the very beginning of time. This knowledge, we hope, brings a profound sense of belonging and wonder. It invites you to find solace in the vastness, to recognize the intricate beauty in every atom, every star, every galaxy. It encourages a meditative state where the boundaries between self and cosmos gently blur, and a deep sense of peace settles upon your spirit. The journey of discovery, both outward into the cosmos and inward into contemplation, is an endless one. There will always be new horizons to explore, new questions to ask, new wonders to behold. Future generations, armed with even more sophisticated instruments and even deeper insights, will continue to unravel the universe's secrets, pushing the boundaries of our knowledge in ways we can only begin to imagine. Perhaps they will finally detect dark matter, or discover definitive proof of life beyond Earth, or even glimpse the contours of another universe. The story of the cosmos, and our place within it, is a narrative that is perpetually being written. For now, as the gentle quiet deepens around you, we invite you to carry these cosmic echoes within your heart. Let the grandeur of the universe inspire not only curiosity, but also a profound sense of tranquility. May the knowledge that you are a part of something so unimaginably vast, so ancient and so beautiful, bring you a deep and abiding peace. As you prepare for rest, let your thoughts drift and find stillness, knowing that the universe continues its majestic dance, and you are an integral, cherished part of its eternal rhythm. The stars, those distant suns, continue to shine, whispering their ancient stories across the light years, inviting you to dream of all that is and all that is yet to be discovered. This cosmic journey, though pausing here for a moment, lives on within you, a wellspring of wonder, calm, and endless possibility. Sleep well and dream of the stars.